Okay, good morning, everyone. Um, just needed some assurance that you are able to see the screen.
Yes, sir.
Great, thank you. Thank you very much. Okay, so we will continue from where we left off last time. Finished the examples and some problems regarding continuous random variables. We talked about the expectations of finding the expectations of continuous random variables, answering probability questions about continuous random variables. And we wrapped it up by talking about the moment generating functions, MGF. Today, I'm going to talk about continuous random variables, but jointly continuous random variable. Remember when we talked about the discrete random variables, we started with one discrete random variable and we said that you can answer probability questions about multiple discrete random variables involved, drawn from the same sample space. Okay. So today we are going to talk about the joint continuous random variables. And the concepts are fairly similar to the discrete case, except that the probabilities here are, calculated incrementally using integrals instead of summations. So if you recall, for a single continuous random variable, for single continuous random variable, we had defined the probability density function of x as integral over this event A, x belonging to A, this set A, this function fx x dx. So if there is a random variable x such that x belonging to this interval A is given by this integral over this interval A of some function fxx dx. Agar ye probability is given by that function, then this guy, the integral of this function, this guy is the PDF of the random variable x. This is the probability density function. Similarly, we can define the probability density function for two continuous random variables drawn from the same sample space. एक ही sample space है, उसके जो sample points हैं, map किया उनको real line के ऊपर, एक और mapping की, you got another continuous random variable. So now you have two continuous random variable, let's say x and y. So you can be asked a probability question. What is the probability x belongs to an interval A and y belongs to an interval B? X belongs to an interval A, y belongs to an interval B. What that means is, an example of x belonging to interval A is x between 5 and 9. X between 5 and 9 could be an example of this x belonging to A. Okay. So this is given by integral over B and integral over A. So integral of x, integral over y of another function fxy, function of two variables x and y, dx dy. If there is a function fxy which satisfies this equation, okay, for every A and for every B, the probability that x belonging to A and y belonging to B is given by this integral, that integral y belonging to B and x belonging to A. If it is given by this, then this guy here, just like in the case of single random variable, हमने define किया था कि ये fxx जो है ये probability density function of x. Okay. Similarly, if there is a function which satisfies this equation, this is called the joint PDF, the joint probability density function of x and y. x और y का ये joint probability density function है. An example of this would be, what is the probability that x is between 1 and 5 and y is between 3 and 7? And the answer to that would be x going from 1 to 5 and y going from 3 to 7. X going from 1 to 5, y going from 3 to 7, f xy dx dy. And the order of integration does not matter as long as you are being careful about these limits. In limits के बारे में अगर careful हो तो order of integration does not matter. Sometimes these limits are x की जो limits हैं वो y के terms में होंगी, y की limit x की terms में होंगी. So in that case you might have to be careful about the order of integration. But in this example, x going from 1 to 5, y going from 3 to 7, it doesn't matter which order do you integrate the function here. Okay. So fxy, this guy here, this is the joint PDF. This answers all the probability questions about x and y. Answers all the probability questions about x and y. Well, not just about x and y. This answers all the probability questions about x only. खाली x के बारे में भी अगर कोई हमारा probability question, what is the probability x going between 1 and 5? This joint PDF will also answer that question. How? So if I'm asking what is the probability x is between 1 and 5, okay? ये एक ऐसा क्वेश्चन है जिसके लिए मुझे सिर्फ x का मार्जिनल PDF चाहिए, x का PDF चाहिए, सिर्फ x का PDF चाहिए. I don't need the joint PDF. But let's say you are given the joint PDF, and from the joint PDF you are being asked a question which only involves x. उसमें हम y का कुछ रखते ही नहीं, ठीक है? So you can always write this guy as probability x going between 1 and 5 and y going from minus infinity to plus infinity. y कुछ भी हो सकता है, y कुछ भी हो सकता है. So these two events are equivalent. X going between 1 and 5 is the same as x going between 1 and 5 and y going from minus infinity to plus infinity. Now this guy can be computed as y going from minus infinity to plus infinity, x going from 1 to 5, and y going from minus infinity to plus infinity, f xy dy dx. And this guy in here, ये क्या चीज है? ये हमने किया है कि this was our joint PDF को हमने y के ऊपर इंटीग्रेट कर दिया, इंटीग्रेट from minus infinity to plus infinity. Now if you recall from the discrete case, जहां पे हमने कहा था कि discrete case में if you have a joint PMF of x and y, अगर x को sum out कर दें over all possible values of x, you are left with the marginal PMF of y. It's exactly the same thing. Okay, if you have a joint PDF, fxy, you integrate out y from minus infinity to plus infinity. What you are left with is the marginal of x, marginal PDF of x. So this would be fx of x. So I'm going to rewrite that as x going from 1 to 5. और ये अंदर वाली जो चीज है जिसमें हम y को हमने minus infinity से plus infinity तक integrate out कर दिया, this is just simple fx of x and dx. This is the probability x between 1 and 5. And this is, we know is true कि x का जो PDF है, marginal PDF of x, उसको हम 1 से 5 तक integrate कर दें तो हमारे पास यही आंसर आना चाहिए कि x going between 1 and 5. So if you are given the marginal of x, you can use this. If you are not given the marginal of x, you can always find the marginal of x by integrating out y out of the joint. अगर joint आपको दिया हुआ हो, joint में से y को integrate out कर दें from minus infinity to plus infinity, you will be left with the marginal of x. If you integrate out x, then you will be left with the marginal of y, of course. Okay. So it is no surprise that fxy double integrates to 1, integrates to 1. When I say integrates to 1 means integration over x and integration over y. Integrates to 1. ठीक है? This plus fx of x, ये हमने पहले देखा, is equal to minus infinity to plus infinity fxy xy dy. Y को integrate out किया, तो you are left with the marginal of x. When x and y are jointly continuous, it is important to identify the region of integration. ये region of integration को identify करना जरूरी होता है. कैसे? आपको example देते हैं. So the example is, so let's say you are given a joint PDF fxy xy as 2e to the minus x e to the minus 2y, where y and x are between 0 and infinity, both going from 0 to infinity. So this limit indicates the region over which the joint PDF of x and y is non-zero. So x की भी जो range है हमारे पास वो 0 से infinity और y की भी 0 से infinity है. So this will probably look something like this. ये x है और ये y है. So this is the region that we are talking about, जहाँ पे आपके पास joint PDF is non-zero. Joint PDF is non-zero. The region that ये जहाँ पे हम read कर रहे हैं. बाकी यहाँ पे joint PDF 0, joint PDF 0, joint PDF 0. Only in the first quadrant you will have the joint PDF as non-zero. Okay? And let's say we are asked some probability questions. कुछ probability questions हमसे पूछे गए हैं. Okay? First of all, what is the probability that x is greater than 1 and y is less than 1? X is greater than 1 and y is less than 1. Let me just try to draw that region. ठीक है? ये region draw करते हैं. PDF नहीं अभी हम draw करेंगे, लेकिन ये region draw कर देते हैं. X greater than 1 and y less than 1. Y less than 1 का मतलब है कि anything under this line. ये अगर 1 हो तो under this line. And x greater than 1 का मतलब है कि anything to the right side of this line. Anything to the right side of this line. So the region that we are talking about here, is actually this region. ये वाला जो region है ये सारा 0 से ये 1 से लेके infinity तक. This region, इस region के ऊपर हमने integration करनी है. इस region के ऊपर integration करनी है. And how do we integrate over this region? It's very easy. कि y going from, जो हमसे पूछा गया है, 0 to 1, y cannot be less than 0 because it is given that y is between 0 and infinity, x is between 0 and infinity. So y going from 0 to 1 and x going from 1 to infinity, क्योंकि x can be all the way up to infinity, joint PDF को integrate करते हैं 2e to the minus x e to the minus 2y dx dy, and you are done. And the integration is not any difficult than a single integration को 2 दफा कर दें. ये बिल्कुल आसान integration है. It would have been slightly tricky अगर exponential की power में x plus x multiplied by y आ रहा होता. But we could handle that. So you can solve this. ये notes में solve भी किया हुआ है. Very easy integration. I will leave it up to you to solve it at home. Okay. Let me ask another question about the same joint PDF. Same joint PDF के बारे में कोई और सवाल पूछते हैं. And that question involves both x and y. X is less than y. X is less than y. Now, what region we are talking about here? The region that we are talking about here is, ये इसको मैं copy करता हूँ. Copy and paste. Okay. So now we are talking about some other region. ये क्या region है? So see, if you have x and y along the x and y axis, then this line, this red line here, is when x is equal to y. X is equal to y along this line. Okay. And the region where x is less than y, the region where x is less than y is this region. ये जो सारा region, ये सारा region है. So ये all the way going up to infinity, infinity तक जा रहा है. So I have to integrate over this region. इस region के ऊपर मुझे integrate करना है. इस region को इंटीग्रल की शक्ल में कैसे लिखेंगे? इंटीग्रल की शक्ल में बड़ा आसान है. इंटीग्रल की शक्ल में ऐसे लिखेंगे कि the probability x less than equal to y is equal to double integral over the region x and y, such that x is less than y, ठीक है, of our joint PDF, which is e to the minus 2y dx dy, ठीक है. अब ये लिमिट्स ऐसे तो इंटीग्रेट कर नहीं सकते हैं, तो इसको इंटीग्रेट करने के there are multiple तरीके. You know, we can integrate by using some horizontal strips here, or we can integrate by using vertical strips here and integrating over this region. So कोई सा भी use कर लें. In the notes we have used one, and I'll show that to you, and that is by considering that y going from 0 to infinity and x going from 0 to y, and I'll explain what that is. 2 e to the minus x e to the minus 2y dx dy. So y is going from 0 to infinity and x is going from 0 to y. So see, ये इस तरह की situation है कि x is going from 0 to y. So ये line है, इस line के ऊपर x is equal to y है, ये वाली जो line है इसके ऊपर x is equal to y है. So I am trying to integrate over this green line. ये horizontal green line जो है इस पर integrate किया, ये इसके ऊपर integrate करें तो x is going from 0, here x is equal to 0 and here x is equal to y. So x is equal to 0 to x is equal to y. यहां से यहां तक इंटीग्रेट कर दिया, तो ये एक हॉरिजॉन्टल लाइन के ऊपर आपने एक थिन स्ट्रिप के ऊपर आपने एरिया डिस्क्राइब कर दिया. बट दिस इज नॉट जस्ट वन थिन स्ट्रिप. इस तरह की ग्रीन स्ट्रिप्स बहुत सारी होंगी. एक ये ग्रीन स्ट्रिप है, एक इस जगह पे होगी, ठीक है, फिर एक और ग्रीन स्ट्रिप होगी, फिर एक और होगी, फिर एक और होगी, फिर एक और होगी, एंड ऑल द वे फ्रॉम y going from 0 to y going to infinity. Y to infinity. So y going from 0 to y to infinity आपने इंटीग्रेट कर दिया, in which x is equal to x going from 0 to y. Now you will notice कि the limits on x is a function of y. तो ये मैं इस वाली इंटीग्रल को बाहर नहीं खींच सकता. Order of integration in this case is of due importance. So उसका जरा ख्याल रखना होगा. So once you have done this, then the integral is very easy. एक्सपोनेंशियल को इंटीग्रेट करना है बहुत आसान है, ये दो लाइनों में इंटीग्रेट हो जाएगा. There is nothing tricky in the integral. एक्सपोनेंशियल की इंटीग्रेशन हमने पहले सिंगल के केस में भी देखी और इसको दो दफा सिंगल करके करते हैं. The only thing you will need to do is to put the limits after the first integral and then integrate again. So इसको अगर सॉल्व करेंगे आपके पास प्रोबेबिलिटी आ जाती है is 1/3 x less than 1.
Sir, can you please explain ये जो y की इंटीग्रेशन वाला पार्ट है?
कौन सा जी?
यहाँ पे आपने y वाली लाइन ड्रॉ की है सर, 0 से इंफिनिटी जो y जा रहा है सर.
यार ये डबल इंटीग्रेशन है, इट्स सिंपल. एक मैंने ग्रीन लाइन की एक अगर ग्रीन स्ट्रिप को कंसीडर करूं तो along that green strip x goes from 0 to y, लेकिन I don't want to integrate over just one green strip, क्योंकि मैंने ये पूरा का पूरा एरिया, ये जो है ये ट्रायंगल सी जो बनी हुई है going from 0 to infinity, इस पूरे एरिया के ऊपर इंटीग्रेशन करनी है. So one green strip is given by this internal, and then I vary y from 0 to infinity. Y को मैं 0 से infinity तक ले जाता हूँ. So think of this y going from 0 to infinity as a collection of all of these green strips, ये going from 0 to infinity. So y जो है वो 0 से infinity तक आपका जा रहा है, ठीक है?
Yes sir, ठीक.
Okay, so the probability that x is less than y is 1/3. Any guesses what would be the probability x greater than y? ये क्या होगी? Answers in the chat window. कोई guess कर सकते हैं? एनी गेसेस? कोई गेस नहीं करना चाहता? Yeah, 2/3, 2/3. And why is that? क्योंकि we know that the probability x is equal to y is 0. X taking a point value, y taking a point value would be 0. Point value continuous के केस में हमेशा 0 होती है. Now, I'm going to ask another question. And this question is simply x less than a. How do I answer this probability question? A is some constant. A is a constant. How do I answer this question? This question can be answered again by considering this region. Here we have x, we have y. So first quadrant is the region where the joint PDF is non-zero. I want x to be less than a. So x is equal to a at this point. So I want the integration over this region. ये जो green मैंने shaded कर दिया है, इस green shaded region के ऊपर इंटीग्रल आपने करना है. ये कैसे इंटीग्रेट कर सकते हैं? अगेन think about it कि ये किस तरह से इंटीग्रल होगा. ये now I am going to look at ये green erase कर देते हैं. So maybe I show you कि ये वाला जो रीजन है, इस सारे रीजन के ऊपर हमने इंटीग्रल करना है. I have to integrate over this region. So इस रीजन के ऊपर कैसे इंटीग्रेट करेंगे? अगेन वही ग्रीन स्ट्रिप्स कंसीडर करते हैं. ईच ग्रीन स्ट्रिप x गोइंग फ्रॉम 0, यहाँ पे x इज इक्वल टू 0 है और यहाँ पे x इज इक्वल टू a है along this green strip. एक और ग्रीन स्ट्रिप कंसीडर करें, वहां पे भी x इज इक्वल टू 0, x is equal to a, and these green strips all added together going y going from 0 to infinity. So this would be y going from 0 to infinity fxy, which is 2 e to the minus x e to the minus 2y, okay, dy. Okay. And then x going from 0 to a dx, x going from 0 to a dx. Now, what you might notice is you might recognize this guy here. You might recognize this guy here as this is the joint PDF जिसमें से हमने y को इंटीग्रेट आउट कर दिया. इंटीग्रेट आउट मींस कि y को माइनस इन्फिनिटी से प्लस इन्फिनिटी तक ले गए. ठीक है, वेल लग रहा है कि 0 से इन्फिनिटी तक ले गए, बट रियली 0 से कम तो y हो ही नहीं सकता, बिकॉज y की जो रेंज ही हमने ऐसी दी हुई है, y इज ओनली फ्रॉम 0 टू इन्फिनिटी. अगर माइनस इन्फिनिटी से प्लस इन्फिनिटी कर दें तो भी यही आंसर है, So this is the marginal PDF of x. And really, if you think about it, कि ये जो हमारे पास आ जाएगा x going from 0 to a fxx dx, this should be the answer, that probability x is less than a. Less than a or less than equal to a की आंसर है उसका continuous के केस में. And that is exactly what we have found here. जी वकास. Okay, so I have just muted you. Now, so I will give you one more example of a joint PDF, pictorial view of joint PDF. So joint PDF का pictorial view.
जो पीछे हमने ये एरिया ये हमने कैलकुलेट इंटीग्रेशन की है. इसमें सर मेरी आवाज आ रही है?
जी आ रही.
सर ये मुझे कंफ्यूजन ये हुई है कि हमने एक्स वाइज करना था, लेकिन मुझे ऐसे लग रहा है जैसे हमने वाई वाइज कर लिया.
कहाँ पर?
जैसे डायग्राम में हमने एक्स हॉरिजॉन्टली किया है, यानी एक्स इज इक्वल टू पहले एक्स 0 वाला, फिर एक्स की वैल्यू को इंक्रीज करते हुए इंटीग्रेट किया है, और फिर हमने उसको वाई वाइज किया है डायग्राम में. लेकिन जब हम उसको इंटीग्रेट कर रहे हैं फॉर्मूला में, वहां पे है पहले हम उसको वाई वाइज यानी वर्टिकल मुझे फील हो रहा है कर रहे हैं हम. ये जरा मैं थोड़ा सा सर कंफ्यूजन है, प्लीज क्लियर कर दीजिएगा.
जी. सो आपने इस ब्लू एरिया के ऊपर इंटीग्रेशन करनी है. सो ईदर यू कंसीडर दीज ग्रीन स्ट्रिप्स और यू कंसीडर दीज रेड स्ट्रिप्स. ये रेड स्ट्रिप्स करें, दोनों के केस में आंसर एक ही आएगा. दोनों के
जी
केस में आंसर एक ही आएगा। यहाँ पर जो शो किया हुआ है ये वाला शो किया, रेड लाइंस वाला शो किया।
जी बिल्कुल ठीक, बस वो यही कंफ्यूजन हो रही थी कि वो डायग्राम में हम हॉरिजॉन्टली और
जी
फार्मूला में
ओके ओके, थैंक यू।
थैंक यू सर, थैंक यू।
जी नो प्रॉब्लम। So it really doesn't matter. By the way, sometimes it is easier to integrate one way and difficult to integrate the other way. You just have to, after a little bit of practice, जो homework से आपको मिल जाएगी, after a little bit of practice, you should be able to see कि एक तरह से integration बहुत आसान हो जाएगी. And by the way, ये जो integration है, यहाँ पे you might realize कि ये जो आपको joint PDF दिया गया है, ये जॉइंट पीडीएफ जो है इसको शायद आप रिकॉग्नाइज भी करें कि ये कोई एक्सपोनेंशियल से मिलता जुलता है, कि ये e टू द माइनस x जो है ये एक्सपोनेंशियल रैंडम वेरिएबल विद लैम्डा इज इक्वल टू 1 है, और 2e टू द माइनस 2y ये एक और एक्सपोनेंशियल रैंडम वेरिएबल विद लैम्डा इज इक्वल टू 2 है। सो इट इज एक्चुअली दैट केस। तो इंटीग्रेशंस जो है वो बहुत आसान हो जाती हैं if you recognize some well-known results. So exponential के केस में मुझे पता है कि CDF क्या होता है, पहले से इंटीग्रेट करके रखा हुआ है। I already know कि exponential की expected value क्या होती है, पहले से हमारे ज़हन में। So most of the question you should be able to answer about this particular question by just recognizing कि ये आपके पास exponentials हैं। Detailed working जो है वो in integrals की वो notes के अंदर दी गई है, तो please make sure करें कि आप उसको देख लें। Okay? So now I'm going to show something, a joint PDF here. This is showing a joint PDF. एक joint PDF show कर रहे हैं। इसमें you will notice that we have x along this axis and y along this axis. X along this axis, y along this axis. Okay. कोई फर्क नहीं पड़ता है, x जिस मर्जी एक्सिस पे ड्रॉ करना है, ठीक है। So if I am asked a question, okay, what is the probability that x is between 0 and 5, x is between 0 and 5, and y is between 5 and 10, y is between 5 and 10. So ये मुझे अगर आंसर करना हो, so x between 0 and 5 is between these 2 points. ये है आपके पास, x is 0 and x is 5. And y between 5 and 10 is this line. Y is 5 and y is 10. Okay. So in this case, basically what the region that we are talking about, is this region. ये वाला region है। इस region के ऊपर आपको इंटीग्रेट करना है इस फंक्शन को। So see, this is a 2-dimensional function. तो ये एक डायमेंशन में x जा रहा है, दूसरे डायमेंशन में y जा रहा है, एक में x एक में y, and the vertically height of the function is given in the third dimension. ये height of the function है, ठीक है। जब एक 1-dimensional function हो आपके पास, तो उसमें आप ऐसे शो करते हैं कि यहाँ पे x शो कर दिया और यहाँ पे fx शो कर दिया, तो आप ये ऐसे प्लॉट कर देते हैं। बट 2D फंक्शन के अंदर you show x on one axis, y on another axis, जो obviously आपस में orthogonal होते हैं, and then the vertical you can show as the height of the function. So ये आपके पास 2-dimensional function हो जाएगा। 3-dimensional function हम पेपर के ऊपर शो ही नहीं कर सकते, ठीक है। So x between 0 and 5, y between 5 and 10, you integrate over this region. Now I'm going to ask another question. Another question is, what is the probability that x is between 0 and 5? This is the probability question which does not involve any y. लेकिन हमारे पास दिया हुआ joint probability density function है। If the joint PDF is given to you and you are being asked the question, what is the probability x is between 0 and 5? So I know that x is between 0 and 5. अब ये मैं green color में draw कर रहा हूँ। X is 0 here and x is 5 here. So I have to integrate over this entire region going from 0 to by going from minus infinity to plus infinity. Okay. So ये सारे region के ऊपर, ये जो green पूरा हमने शो किया हुआ है, इस पूरे रीजन के ऊपर आपने इंटीग्रेट करना है, इस पूरे रीजन पे इंटीग्रेट करना है। एंड ऑफ कोर्स यू कैन रियलाइज कि ये वाला जो प्रोबेबिलिटी क्वेश्चन है which only involves x can be written as x going from 0 to 5 and y going from minus infinity to plus infinity, fxy, which is shown here, xy dy dx. Okay, and this guy internally, I also recognize this is equal to x going from 0 to 5 fxx dx. Okay, so important to realize कि किस रीजन के ऊपर आपने इंटीग्रेट करना है, उसको एक्यूरेटली फाइंड आउट करना जरूरी होता है. Okay, now just like in the case of single continuous random variable, we had a relationship between CDF from PDF and vice versa. CDF from PDF and vice versa. Okay. कैसे निकालते थे? इंटीग्रल या डिफरेंशियल से निकालते थे. So let's say you have a joint CDF of x and y. This is given by the probability x takes a value less than or equal to a, y takes a value less than or equal to b. This is how the joint CDF is defined, and of course in integral terms this would be minus infinity to a and y going from minus infinity to b, fxy xy dy dx. So from the CDF you can find the PDF. जिस तरह सिंगल के केस में होता था, इसको कैसे मालूम करेंगे? You take the derivative, but since you have two variables here, you take the partial derivative. So partial square of partial a partial b of fxy a comma b. And how do you find the CDF from PDF? By integrating the PDF. Integrate करें PDF को minus infinity to a and minus infinity to b. So PDF को integrate करें तो आपके पास CDF आ जाएगा, और CDF को differentiate करें तो आपके पास PDF आ जाएगा. Joint के केस में भी वही है. Okay. So now I'm going to give you another example which involves two continuous random variables, and this example is fxy xy. This joint PDF is given to us as e to the minus x plus y. Again, x going from 0 to infinity and y going from 0 to infinity. And you can again realize that this is e to the minus x multiplied by e to the minus y. Both are exponential random variables, each with parameter lambda is equal to 1. Lambda is equal to 1. Okay. So let's say you are given this joint PDF. You are given this joint PDF. Okay. Let's say you are asked to find the PDF of x over y. PDF of x over y. See, x over y would also be a random variable. It's a function of two random variables. It would be a random variable. Okay. Let me define w to be that random variable. W is equal to x over y. So in other words, what we are being asked is to find the PDF of w. Find the PDF of w. A standard procedure for finding, or one of the standard procedures to find the PDF of w is to first find its CDF. ये हमने कुछ homework में examples भी की हुई हैं. So fw of small w is equal to the probability capital W is less than or equal to small w. ये इसका CDF है. But capital W is x over y is less than or equal to small w, okay, which is equal to the probability x is less than or equal to w times y. W times y. Aha. So now let me just show you कि ये हमें इस probability question का आंसर कैसे मिलेगा. इस probability question का आंसर हमें again integration से मिलेगा, but I have to identify that region of integration. I have to identify that region of integration. वो हम रीजन ऑफ इंटीग्रेशन कैसे मालूम करेंगे? रीजन ऑफ इंटीग्रेशन ऐसे मालूम करेंगे कि इफ यू अगेन कंसिडर दिस एक्सिस x and y, in the first quadrant we have a non-zero PDF, बाकी सब छोड़ दें उसको. So in the first quadrant, if you look at this line, ये वाली एक आपके पास dotted line है, this is the line when x is equal to y, and this is the line x is equal to 2y. This is the line x is equal to 2y, इसी तरह 3y. So maybe there is a line जिसकी slope इस तरह change होती है. So this would be x is equal to w times y, depending upon what w is. अगर w जो है वो 1 से बड़ा होगा तो ये ऐसी लाइन होगी, 1 से छोटा होगा तो ये इस तरह की लाइन होगी. So x is equal to w times y. W will define the slope of this line, will define the gradient of this line. Okay. So what this probability is basically answering this question. Okay, double integral over the region x comma y such that x is less than w times y, x is less than w times y, e to the minus x plus y dx dy. इस रीजन पे इंटीग्रेट करना है. और ये रीजन जो है, अब हम अलग-अलग इंटीग्रल्स में कैसे रखेंगे? इसको ऐसे लिखेंगे कि x going from 0 to a times, going from 0 to w times y, everyone agrees के ये जो x की लिमिट है वो इसको सेटिस्फाई करती है. हमारी जो ये कंडीशन है, इस रीजन की जो कंडीशन है, बाउंड्री को सेटिस्फाई करती है. x going between 0 and w times y, so this satisfies here, and y going from minus infinity to plus infinity, but y is always greater than 0, so y going from 0 to infinity, e to the minus x plus y dx dy. So अगर इसको इंटीग्रेट करके भी देखें, y is equal to 0 to infinity, and this would be e to the minus x multiplied by e to the minus y, e to the minus x multiplied by e to the minus y. So e to the minus y तो मैं वैसे ही बाहर खींच सकता हूँ, e to the minus y वैसे ही बाहर खींच सकते हैं. So x going from 0 to w times y, e to the minus x, which would be minus e to the minus x, उसका integral, and then put the limits x going from 0 to w times y and dy. ये हमने अंदर वाले इंटीग्रल को सॉल्व कर दिया. e to the minus y बाहर खींच लिया और e to the minus x को इंटीग्रेट कर दिया. Put the limits and then you will get y going from 0 to infinity, e to the minus y, and this would be 1 minus e to the minus wy dy. अब ये सिर्फ y की टर्म्स में इंटीग्रल रह गया. And this integral, by the way, again, एक तो ये है तरीका कि इसको बैठ के सॉल्व करते रहे. दूसरा तरीका ये है कि recognize कि y going from 0 to infinity, this is e to the minus y, minus integral y going from 0 to infinity, e to the minus w plus 1 y dy. इन दो इंटेग्रल्स में अलग कर दिया. ठीक है. Now, what is this guy? What is this guy? If somebody can quickly recognize this, कोई आंसर देना चाहता है चैट विंडो के अंदर कि इसका आंसर क्या होगा पहले वाले इंटीग्रल का? I don't need to solve it. इसका आंसर मुझे डायरेक्ट ही पता होना चाहिए. This should be 1. Why? Because this is the integral of an exponential random variable. जो lambda e to the minus lambda x होता है उसको इंटीग्रेट करें तो 1 आना चाहिए. उसको इंटीग्रेट करें तो आपके पास 1 आना चाहिए. So this is an expression जिसमें lambda is equal to 1 है. So what about the second expression? ये जो second वाली है माइनस के बाद वाली, ठीक है, इसका क्या आंसर होना चाहिए? Answers in the chat window. ये भी बहुत आसान है. Well, this would have been lambda e to the minus lambda x. अगर मेरे पास यहाँ पे एक w plus 1 होता तो डाल देते हैं w plus 1. अगर डाल दिया तो to be fair यहाँ पे w plus 1 से डिवाइड भी कर देते हैं. ठीक है. सो इसका आंसर आ जाएगा 1 over w plus 1, और आगे वो जो इंटीग्रल है lambda e to the minus lambda x, उसको इंटीग्रेट करें तो वो आपके पास फिर 1 आना चाहिए. So 1 minus 1 over w plus 1, which will turn out to be 1 over W over W plus 1. And now realize that since W is the ratio, W is the ratio of X and Y, W is the ratio of X and Y. So X की limit has 0 से infinity, Y की limit has 0 से infinity. W can never be negative, So W will also have the limit 0 to infinity. It is very important to specify the limits. अच्छा, ये तो CDF आया है. This is FW of small w. The PDF is going to be just the derivative of this guy. And the derivative of this guy, it will be 1 over W plus 1 whole square. Once again, 0 less than W. Okay. So now I'm going to talk about a conditional PDF continuous case. We talked about the conditional PDF in the discrete case, but now I'm going to talk about the conditional PDF for the continuous case. In exactly the same way, if you recall, कि discrete के case में क्या था? Discrete के case में I will recall that कि P of X given Y, X given Y is equal to the joint PMF X and Y divided by the marginal PMF of Y. ये discrete के case में था, discrete के case में. By the same token, continuous के case में, there is some more description of this in the notes. Continuous के case में, this will be similarly f of X given Y, X given Y is equal to the joint PDF of X and Y divided by Fy of Y, the marginal of Y. One thing I would like to mention here is that although the probability that capital Y takes a value small y, the probability of that event is 0. I can still condition on that. ये मैं उसके ऊपर फिर भी condition कर सकता हूँ. ठीक है. So I will give you an example here. Let me see what example is the best example to give. I will actually give you a couple of examples. दो examples देते हैं. पहली example जो है वो I will just give you an insight. So let's say you have a circle. You have a circle of radius r, of radius r, of radius r. So let's say that there is a point which is randomly chosen on this circle. ये कोई point आपने choose कर लिया इसके ऊपर x, y. So there is some x value and then there is some y value इसकी. And x and y can also be negative. So x can be from minus r to plus r and y can be also minus r to plus r. So the region over which the probability density function exists is this circular region. इसके बाहर नहीं exist करता. And you are given that fxy, the joint PDF only exists over this region and it is uniform, which means that it is constant. ये कोई constant है c. ठीक है? When if x square plus y square is less than equal to r square. ये circle की expression है and x square plus y square less than r square का मतलब है कि anything inside this circle. anything inside this circle, and it is 0 outside this circle. ठीक है? So सबसे पहले तो easy सवाल है कि find C. C कैसे find करेंगे? Well, C find करने के लिए we know okay, you integrate over this circular region x comma y such that x square plus y square is less than equal to r square fxy xy dx dy. So fxy dx dy. So ये fxy जो है ये तो वैसे ही कांस्टेंट है, तो मैं इसको चेंज करके कांस्टेंट ही कर देता हूँ. इसको चेंज करके ये मैं कांस्टेंट कर देता हूँ c. ठीक है? And this would be c and the area of the circular region. C and the area of circular region which is pi r square. ये सबको पता है. इसको इंटीग्रेट कर भी सकते हैं if you want. You probably would have done it back in the days. कभी फर्स्ट ईयर कैलकुलस के अंदर किया होगा. Not too difficult to integrate, but again this should be equal to 1. This should be equal to 1. Why? Because this is a PDF. So C would be equal to 1 over pi r square. 1 over pi r square. R is a constant. एक radius है उसका. Okay. Then हमने ये notes में show किया हुआ है कि you will be able to show that fxx, which is the marginal of x, is not uniform. Marginal of x is not uniform. And the reason for that is कि अगर मैं y को integrate कर दूं, let's say from this point to this point. So ये जो x का जो PDF है, it does not turn out to be uniform, and the reason for that is कि अगर मैं इस strip को थोड़ा सा इधर यहाँ right पे move कर दूंगा, तो now y की range जो है वो बढ़ गई है. So x will have more values to take. ठीक है? So fxx will turn out to be not uniform. But given a specific y, एक specific y अगर आपको दे दें, f of x given y is uniform. ये mathematically show भी कर सकते हैं, and it is shown in the notes. ये notes से आप जरूर consult करें. I will give you one more example of conditional PDFs. So let's say you are given a joint PDF fxy xy is equal to e to the minus x divided by y, e to the minus y divided by y. This is the joint PDF, and once again here x is between 0 and infinity and y is also between 0 and infinity. So this is the joint PDF of x and y which is given to us, again non-zero in the first quadrant only, and I am being asked the question that find the probability x is greater than 1, given y is equal to y. In order to answer this question, I need a conditional PDF of x given y is equal to y. Given capital Y is equal to small y, I need the conditional PDF of x. Okay. So how do I solve this? Okay. To solve this, I need to find f x given y, okay, which we have seen is given by the joint of x and y divided by the marginal of y. So we do know the joint of x and y, but we don't know the marginal of y. But we can find the marginal of y. How do I find the marginal of y? In order to find the marginal of y, consider that fy of y is equal to, how do I find that? Integrate out x from the joint. Joint में से x को integrate out कर दें, x going from 0 to infinity, जॉइंट में से इसको इंटीग्रेट आउट कर दें, e to the minus x over y, e to the minus y over y dx. This should give you the marginal of y. This should give you the marginal of y. So the integral might look intimidating, but it is actually very, very simple. Very, very simple. क्योंकि e to the minus y over y ये तो कांस्टेंट है, ये तो वैसे ही बाहर निकल आएंगे. So e to the minus y over y इधर आ गया, and x going from 0 to infinity, e to the minus x over y dx. What would be the answer of this integral? ये जो मैंने बॉक्स में कर दिया, इसका आंसर क्या होगा? आंसर इन द चैट विंडो. अभी इस तरह की कोई चीज की है. What would be the answer to this? The answer to this would be fy of y is equal to e to the minus y over y. This would be equal to well, देखें, ये हमें पता लग रहा है कि ये कुछ एक्सपोनेंशियल टाइप की चीज है. लैम्डा e to the minus lambda x, where lambda is equal to 1 over y. तो ये वाला लैम्डा मिसिंग है, तो एक 1 over y से यहाँ पे मल्टीप्लाई कर देते हैं और एक 1 over y से डिवाइड कर देते हैं. सो ये अब जो इंटीग्रल के अंदर चीज है वो 1 बन जाएगी और ये एक y हमारे पास आ जाएगा. सो दिस वुड बी इक्वल टू e to the minus y. वेरी नाइस. देखें, कुछ इंटीग्रेशन करने की जरूरत नहीं पड़ी जाती. Not just that, we also recognize that fy of y is equal to e to the minus y. This is also an exponential. Okay. Now, f of x given y would be equal to the joint which is e to the minus x over y, e to the minus y divided by the marginal which is e to the minus y. So this turns out to be 1 over y e to the minus x over y. Once again, recognize कि ये जो चीज है ये lambda e to the minus lambda x है. So the PDF of x given y, the conditional PDF of x given y is in exponential. So f of x given y is actually exponential with parameter 1 over y. So if you are given that the random variable y, capital Y, takes a value small y, if it is given to you, given that information, your x is an exponential random variable with parameter 1 over small y. So now you can answer this probability question. Probability x is greater than 1 given that y is equal to y. I know this is f x greater than 1 given y is equal to y. I know, okay, given y is equal to y, x is a exponential random variable. X is an exponential random variable with parameter lambda. And I am being asked, okay, what is x greater than 1? Which should be equal to 1 minus probability x less than equal to 1 given y is equal to y. Okay. And this is the CDF of conditional CDF of x. So this is equal to 1 minus conditional CDF of x. I know कि CDF of x क्या होगा, वही जो exponential with parameter 1 over y का होगा, would be 1 minus e to the minus x over y. Evaluated at x is equal to 1. So this would be equal to e to the power minus 1 over y. I can also find the expected value of x given y is equal to y. So I do know that x given y is equal to y is an exponential with parameter 1 over y So the expected value of x would be 1 over lambda, which is 1 over y, which is y. Expected value of an exponential with parameter lambda is given by 1 over lambda. इसी तरह variance भी बता सकते हैं इसकी, इस तरह variance भी बता सकते हैं. So now I'm going to turn back to another topic that we had already covered: independence of x and y, independence of two random variables where they are continuous. हमने discrete के case में ये cover किया था. Now we are going to cover in the case of continuous. In the case of discrete, we saw that two random variables x and y are independent if and only if I can write probability x belonging to A in region A and y belonging to a support set B is equal to the probability x belonging to A multiplied by y belonging to B. So for every A and B, if I can write this, then x and y are independent. इससे हमने डिड्यूस किया था कि x less than equal to A and y less than equal to A. So CDFs जो हैं वो भी multiply होंगे. Joint CDF would be the joint CDF will be the product of CDFs, of marginal CDFs. Let me just be more clear, of marginal CDFs. Similarly, joint PDF will be the product of marginal PDFs. Okay. Now I'm going to ask you this question. कि ये वाला जो question है, इसमें खैर हमने x का मालूम नहीं किया. Ask you about this question. Yeah. So this guy here, if you are given the joint PDF e to the minus x plus y, r x and y, इसको देख के हम बता सकते हैं कि r x and y independent or not. Are they independent or not? Answers in the chat window. क्या लगता है इसको देख के कि independent हैं या नहीं है? Can I write the PDF of x and PDF of y separately? अगर मैं x और y की terms को अलग-अलग कर सकता हूँ multiplication के तौर पे, तो then I will be able to write the PDF of x and PDF of y separately. PDF of x and PDF of y separately. क्या इसके केस में किया जा सकता है? Are x and y independent? इस केस के अंदर answers in the chat window. Yes. So this can be written as e to the minus x into e to the minus y. E to the minus x into e to the minus y. So in this case, in this particular case, x and y will be independent. So notes के अंदर जो हम upload कर देंगे अभी आज, there will be a couple of more examples of integration. We'll give you practice over integrating the joint PDFs over some different areas. Okay. So I will give you a couple of more examples here. Okay. So one example is the joint PDF of x and y. The joint PDF of x and y is equal to 6 e to the minus 2x e to the minus 3y. 0x infinity, 0y infinity. Are x and y independent? Yes or no? Answers in the chat window. Yes or no? Yes. Independent. Another example. fxy xy is equal to x plus y. X 0 to infinity and y 0 to infinity. Are x and y independent? Yes or no? Answers in the chat window. They are not. I cannot write this as product of an फंक्शन ऑफ x एंड अ फंक्शन ऑफ y. x के फंक्शन और y के फंक्शन के प्रोडक्ट के तौर पर लिख नहीं सकते इसको. So no, not independent, not independent. One more example, fxy xy is equal to 24xy. Zero x1, 0 y1. Are they independent? Yes or no? Yes, they are independent. Why? Because I can write this as the product of these two guys. Now I change this a little bit. इसको थोड़ा सा change करते हैं. एक ये region है आपके पास जिसमें हमने बताया है कि ये PDF जो है exist करता है. Let me add to that region. उसको थोड़ा सा और constraint कर देते हैं. 0 is less than x plus y is less than 1. 0 is less than x plus y is less than 1. So ये पहले जो रीजन था आपके पास, पहले वाला जो रीजन था, so if you have 1 here and if you have 1 here, okay, so जो पहले आपके पास रीजन था, ये मैं ब्लू में ड्रॉ करूंगा. This was the region. This was the region of integration. But with this additional constraint, ये वाला जो है 0 is less than x plus y is less than 1. इसने क्या किया? आपका कुछ और एरिया काट दिया. ठीक है. Now you are only integrating over this region. ठीक है. So by addition of this limit here, are x and y independent? Answers in the chat window. Yes or no? Yes or no? Well, they are not independent. And the reason for that is not कि ये factor out नहीं होता. ये तो factor out हो जाता है. लेकिन limits ऐसी हैं कि हम x और y को अलग नहीं कर सकते वहां से. x और y को वहां से अलग नहीं कर सकते. इसलिए in this case, x and y will not be independent. So I'll give you one more example. एक और example है कि x, y, z, there are 3 random variables. All 3 of them are uniform 0, 1. Let's ask this question. Okay, what is the probability x is greater than equal to y times z? So in this case, we will need the joint PDF of x and y and z. X and y and z. It is also known that x, y, z are independent. So in order to answer this question, I need f, x, y, z, x, y, z. ये हमें चाहिए. ये कैसे मिलेगा? ये ऐसे मिलेगा कि since x, y, z are independent, so I can write it as f, x, x, f, y, y, f, z, z. And the reason I can write it is as a product is because they are independent. Independent है तो joint PDF को हम product of PDFs की शक्ल में लिख सकते हैं. ठीक है. And the product of PDF, this is 1, this is 1, this is 1. So this is just 1. और कुछ भी नहीं है. Okay. So this probability now will be equal to triple integral of x, y, z such that x is greater than y times z. 1 को integrate कर दें, which is the joint PDF of the 3, dx, dy, dz. Again, इसको हम कैसे open कैसे करके लिखेंगे? So that I can integrate in 3 integrals. Okay. So y going from 0 to 1, z going from 0 to 1, and x going from x is greater than yz, so x going from yz to 1. X cannot be smaller than yz. X को हम 0 to 1 नहीं लेके जा सकते. dx, dy, dz. इसको integrate करें and you will get the answer. Very easy to integrate it. ये जो पहले वाली जो दो इंटेग्रल्स हैं जिसमें y की लिमिट है और z की लिमिट्स हैं, इनको ऑर्डर हम इंटरचेंज कर सकते हैं। ये जो अंदर वाला है इसका ऑर्डर हम इसको बाहर नहीं खींच के ला सकते। Why? Because the limits are dependent on y and z. Because the limits are dependent on y and z. तो लिमिट्स की वजह से जो है इंटीग्रेशन में y और z आ जाएगा। So now I'm going to talk about another very important, interesting topic. It's the sum of independent random variables. ये हमने discrete के केस में किया था, but now we are going to do it for the continuous case. Continuous के केस में sums of independent random variables. So let's say you have x, y independent random variables, okay? And I am interested in x plus y. I am interested in x plus y. PDF of x plus y. क्यों उसके PDF में इंटरेस्टेड है? क्योंकि कोई प्रोबेबिलिटी क्वेश्चन है जो हमें आंसर करना है. What is the probability x plus y is between 3 and 7? ठीक है, अगर हमने ये आंसर करना है तो ये कैसे करेंगे? So let's try to answer that question. So first of all, कैसे इसका PDF फाइंड करेंगे? वो हमने जो पहले स्टैंडर्ड प्रोसेस लिया था. First find the CDF. CDF of x plus y evaluated at a is the probability x plus y is less than equal to a. So this is equal to double integral x plus y less than equal to a x comma y such that x plus y is less than equal to a, the joint PDF of x and y, dx dy. So this can be written as y going from minus infinity to plus infinity and x going from, well, x cannot go from minus infinity to plus infinity because x has to be less than a minus y. ये लिमिट हमें ये बता रही है कि x plus y less than a हो, so that means x has to be less than equal to a minus y. So x has to go from minus infinity to a minus y. A minus y से बड़ा नहीं हो सकता ये x जो है. Why? Because this region is telling us. And then you have fxx, fyy, dx dy. And the reason I can write this guy as this is because of independence. Independence की वजह से मैं इसको ऐसे लिख सकता हूँ. Okay. So now I can write the PDF of x plus y. PDF of x plus y a is by differentiate here, इसको differentiate करें अगर with respect to a, differentiate with respect to a. So this would be equal to y going from minus infinity to plus infinity fx of, well, ये fy यहां से बाहर निकल आएगा, and then you will be left with fx of x internally, जिसका कोई इंटेग्रल होगा, कोई इंडेफिनेट इंटेग्रल होगा जिसमें लिमिट्स पुट करेंगे a माइनस y और माइनस इंफिनिटी, फिर a माइनस y से उसको दोबारा से जब वैल्यू पुट कर दी और उसको हम दोबारा इंटीग्रेट करेंगे तो you will be left with fx of a minus y. Okay. I'm skipping a step here. एक दो स्टेप मैंने यहाँ पे स्किप किए हैं, वो नोट्स में दिए हैं, प्लीज उसमें से जरूर देख लें. But you will end up with getting this guy. Okay. And this would be equal to, again, ये x or x plus y, when I say x plus y is the same as y plus x. It's the same as y plus x. Okay. So if I can write this by integrating y from minus infinity to plus infinity, I should be able to integrate with respect to x as well. ये या x के through आप differentiate integrate कर लें. So this would be equal to fx of x into fy of a minus x dx. Fy of a minus x dx. So there are two ways you can find the joint, the PDF of the sum of two independent random variables. या ऐसे मालूम कर लें या ऐसे मालूम कर लें. Y को आप वेरी कर लें या x को वेरी कर लें. And this expression here, and this expression here, these are called the convolution expressions of fxx and fyy. PDF of x and PDF of y, उनके दरमियान हमने ये convolution किया, and there is an example of that, and the example is, okay, let's say you have x which is uniform 0 1 and y which is independently uniform 0 1. Okay. So now we are interested in finding the PDF of x plus y. Now what we are doing here is कि ये हमारे पास x का PDF है 1 1 0. This is fxx and this is fyy. This is fyy 1 1 0. This is y, this is x. हमने इन दोनों PDFs को कन्वॉल्व करना है, इनको कन्वॉल्व करना है. और इनको कन्वॉल्व कैसे करते हैं? इनको कन्वॉल्व हम ऐसे करेंगे, कि if z is equal to x plus y, then fz of small z would be equal to integral minus infinity to plus infinity. या ये पहला वाला यूज कर लें या दूसरा वाला यूज कर लें, कोई सा भी यूज कर सकते हैं. This would be equal to fx, let's say मैं ये वाला यूज करता हूँ, first one, of z minus y into fyy dy. Now we know that fyy is 1 whenever y is between 0 and 1. So this will automatically become y between 0 and 1 fx of z minus y into 1 dy. क्यों? क्योंकि fy of y जो है वो 1 है between 0 and 1. Now we are left with this guy. What about this guy? Now we know that fx of x is 1 between 0 and 1. Is when x is between 0 and 1. When x is between 0 and 1. So now if you look at this function here, इस फंक्शन को अगर देखें तो यहाँ पे fx of z minus y आ रहा है. So whenever z minus y is between 0 and 1, only then fx of that number would be equal to 1. So this is fz of z. ये हमने convolution से find किया. Now in order to find this fz of z, इसके लिए हम मुख्तलिफ रीजन्स कंसीडर कर सकते हैं. पहला रीजन जो होगा, z is less than equal to 0. Now you know that y is between 0 and 1. ये हमें इंटीग्रल बता रहा है, y is between 0 and 1. So whenever z is less than 0, there is no way that z minus y can be between 0 and 1. z जो है अगर 0 से छोटा हो जाए तो y is always between 0 and 1. तो ये 0 से छोटा है, ये कभी between 0 and 1 नहीं आ सकता z minus y. तो अगर ऐसी चीज है तो fz of z would be equal to 0. and you can show that for z greater than equal to 2, for z greater than equal to 2 also z greater than equal to 2, क्योंकि y between 0 and 1 है, क्योंकि y between 0 and 1 है, मैक्सिमम वैल्यू y की 1 हो सकती है, यहाँ पे मैक्सिमम वैल्यू y की 1 हो सकती है if z is greater than 2, so something greater than 2 minus maximum value 1 है, तो वो आंसर हमेशा 1 से बड़ा आएगा, तो this guy is going to be 0. so कुछ हमें आइडिया हो गया कि ये between 0 and 2 इससे पहले जो है आपके पास fz of z ये 0. so what about between 0 and 2, 0 और 2 के बीच में क्या होता है, ठीक है. so उसके लिए केस कंसिडर कर लेते हैं कि when z is between 0 and 1, when z is between 0 and 1, now it will be tricky. When z is between 0 and 1, then fz of z, which is y going from 0 to 1, fx of z minus y dy. I know कि ये z minus y जब भी ये 0 and 1 के बीच में हो तो fx of that number would be equal to 1, otherwise it would be 0. So z minus y falls between 0 and 1. This will cause fx of z minus y to be equal to 1. This is only when y is between 0 and z. When y is between 0 and z. Okay. So y is between 0 and 1. Y is between 0 and 1. ये हमें नजर आ रहा है यहाँ पे इंटीग्रेशन की लिमिट से, ठीक है. So when y is between 0 and z is between 0 and 1, only then you will have a non-zero here. So when y is between 0 and z, then fx of z minus y would be equal to 1. और ये उसकी रीजन क्या है कि whenever y is between 0 and z is between 0 and 1, you will see कि z minus y जो है वो आपके पास 0 और 1 के बीच में फॉल करता है, और जब भी ये 0 और 1 के बीच में फॉल करता है fx of x is 1, otherwise it is 0. So इसको अगर आप इंटीग्रेट कर दें, you will get z, fz of z is z. So between 0 and 1, z between 0 and 1, you get something like this. Okay. And you can show, ये हमने नोट्स में शो किया हुआ है कि between 1 and 2 you get something like this. So ये दो यूनिफॉर्म्स को आपने कन्वॉल्व किया है तो आपके पास ये आंसर आ गया. There is a graphical way of looking at it as well, which is also given in the notes. Please make sure to take a look at that. Graphical way को भी जरा देख लें आप, ठीक है. So one thing that I want to mention here is कि ये जो हमारे पास दो यूनिफॉर्म्स थे, we had a uniform here, इसको मैंने convolve किया. This is the convolution of the convolution operation. So तो ये मेरे पास आपके ये एक ट्रायंगल फंक्शन आ गया. So this was between 0 and 1, 0 and 1, 1, 1, and this is between 0 and 2. This is between 0 and 2. So ग्राफिकल कॉन्वोल्यूशन को आप देखें तो आपको पता चलेगा कि किसी एक को पिक करने, उसको फ्लिप करें और दूसरे के ऊपर स्लाइड करते जाएं, एंड देन उनके प्रोडक्ट को आपने इंटीग्रेट करना है, द एरिया अंडर द प्रोडक्ट उसको इंटीग्रेट करना है, एंड देन यू गेट दिस कर्व. सो एसेंशियली हम यहाँ पे इंटीग्रल से भी यही चीज कर रहे हैं, ये वाली चीज यहाँ से भी ऐसे ही कर रहे हैं. सो टेक अ लुक एट द ग्राफिकल कन्वोल्यूशन. तो the thing that I wanted to mention is कि if you convolve these two guys, जहाँ पे मेरे x और y दोनों ऐड हो रहे थे तो उनके PDF कन्वॉल्व हो गए, तो आपके पास ऐसा PDF आ गया. So you can see that the uniform का PDF is very very abrupt. ये बड़ी एक abrupt change आती है यहाँ पे. So this has been smoothed out a little bit. अगर हम 3 को कन्वॉल्व करेंगे, तो हमारे पास जो है ये थोड़ा सा इस एक को पकड़ के इसके साथ कन्वॉल्व कर सकते हैं. सो दिस विल बी फर्दर स्मूथ्ड आउट अ लिटिल बिट. फिर और करेंगे तो और स्मूथ आउट कर देंगे. सो इफ यू हैव many यूनिफॉर्म्स, बहुत सारे यूनिफॉर्म्स हैं, उन सबको कन्वॉल्व कर देंगे उनके पीडीएफ्स को. सो दैट मीन्स कि आई एम टेकिंग द सम ऑफ मैनी यूनिफॉर्म्स. बट व्हाट डज द सेंट्रल लिमिट थ्योरम टेल अस? Central limit theorem tells us that if you have a sum of random variables, if you have a sum of many uniforms, this starts to look like a normal distribution. और ये हमें नजर भी आ रहा है यहाँ पे कि ये 2 को किया तो ये इतनी स्मूथिंग आ गई उसमें, तीसरे से करेंगे तो और स्मूथिंग आ जाएगी. एंड यू कैन एक्चुअली लुक एट इट. ये वेब के ऊपर कोई टूल आपको मिल जाएगा जिससे आप 2 यूनिफॉर्म्स को कन्वॉल्व कर दें, फिर तीसरे के साथ कन्वॉल्व करें, फिर चौथे के साथ करें, एंड यू विल सी दैट the distribution of the sum starts looking like a Gaussian or normal distribution. And that is exactly what the central limit theorem has told us. Central limit theorem ने भी हमें यही बताया था. So next time we'll talk about the sum of independent random variables, a couple of examples. Gamma की हमने example पहले कर ली थी, उसको हम repeat करेंगे. And then we will talk about the sum of independent normal random variables. Okay? And then we will talk about the sum of independent squares of normal random variables, which is called the chi-square distribution. We'll talk about the chi-square distribution as well. Okay? And then in the next class, we will also talk about how do you quantify the dependency between the random variables. कि 2 random variables हैं, वो अगर independent नहीं है, अगर वो dependent है तो कितने dependent है, बहुत ज़्यादा dependent है या कम dependent है. So we will introduce the concept of correlation and covariance, and then we will go from there. Any questions? कोई question हो before I close the session? No question? Okay, I'm going to stop the share now and close the session. We will upload the video on YouTube as soon as it becomes available. Thank you very much.